Hello everyone and welcome to lecture number 7 of engineering mechanics. In previous lecture we have learned about the calculation of resultant force using graphical method, that is by using triangle law of forces and polygon law of forces. In today's lecture we are going to learn about the calculation of resultant force using analytical method by using parallelogram law of forces and resolution method. Analytical method to calculate resultant force. In this method we are going to use only formulas to calculate the resultant force. Parallelogram law of forces and resolution method. The only difference between the parallelogram law of forces and the resolution method is only the number of forces included in the force system. If number of forces is equal to 2, then we will go for the parallelogram law of forces. If number of forces exceed 2, then we will go for the resolution method. Now let's first discuss the parallelogram law of forces. It states that if two forces acting simultaneously on a particle be represented in magnitude and direction by the two adjacent sides of a parallelogram, their resultant may be represented in magnitude and direction by the diagonal of the parallelogram which passes through their point of intersection. As we see in this figure, that there are two forces F1 and F2 acting simultaneously on a particle separated by an angle theta. So as per this law, it states that if these two forces can be represented by the sides of a parallelogram, then their resultant may be represented in magnitude direction by the diagonal of the parallelogram. So first of all, let's complete this parallelogram. For that I have to draw the force F2 here like this and force F1 like this. This is the angle theta. Now for this parallelogram, this will be the diagonal. Let us say this is R. So according to this parallelogram law of forces, this diagonal is the resultant of these two forces, and it can be calculated as per the formula given. R is equal to under root of F1 square plus F2 square plus twice of F1 F2 cos theta, where theta is the angle between the forces. And if we assume that this resultant makes an angle alpha with the horizontal or with the force F1, then the magnitude of this angle alpha is given by tan alpha is equal to F2 sin theta divided by F1 plus F2 cos theta. So whenever we have two forces acting on a particle simultaneously, the magnitude of the resultant force can be calculated by using this formula, and the angle which it gonna be make with the horizontal can be calculated by this formula. So this law is only applicable if the number of forces are 2 in a force system. If the number of forces exceed 2, then we will go for the method of resolution. So let's first discuss what is method of resolution. What is resolution? The process of splitting up the given force into a number of components without changing its effect on the body is called resolution of a force. Principle of resolution. It states the algebraic sum of the resolved parts of number of forces in a given direction is equal to the resolved part of their resultant in the same direction. In general, the forces are resolved in vertical and horizontal direction. Let's take an example that there is a force making an angle theta is acting in this direction. Then this force can be resolved into two components, that is, one is vertical and the other one is horizontal. Let us say this is the horizontal part and this is the vertical part. Then this will be F cos theta and this will be F sin theta. So this is the resolution of this force. We have resolved this force F into two mutually perpendicular components, F cos theta and F sin theta. Now, method of resolution for the resultant force. If there are number of forces and we have to calculate the resultant of that force, then we need to resolve all the forces given in the force system, and then we have to calculate the resultant of that force. So what's the process? So first of all, resolve all the forces horizontally and find the algebraic sum of all the horizontal components, that is sigma h. Second step is resolve all the forces vertically and find the algebraic sum of all the vertical components, that is sigma v. After finding these two components, sigma h and sigma v, then we can easily calculate the resultant in step 3 by using the equation r is equal to under root of sigma h square plus sigma v square. The resultant force will be inclined at an angle theta with the horizontal such that tan theta is equal to sigma v upon sigma h. Now let's understand this method by using a problem. The problem is find the magnitude and direction of the resultant force of following force system. So there is a force system in which there are four forces, 20 Newton, 25 Newton, 30 Newton and 35 Newton, and their angle of inclination is given with the horizontal. Now we have to calculate the magnitude and direction of the resultant force of this force system. So from the first step we have to calculate sigma h, which means that the algebraic sum of all the horizontal components of this force system. Secondly, we have to calculate sigma v, that is the algebraic sum of all the vertical components of this force system. In step third, we have to calculate the magnitude of resultant r, and finally we have to calculate the angle theta, the angle which the resultant is making with the horizontal. So first of all, let resolve all the forces into its two components, vertical and horizontal. So for this 20 Newton, which is making an angle 30 degree with the horizontal, this will be 20 cos 30 degree, and this will be 20 sin 30 degree. Similarly, this 25 Newton force is acting in north direction then this will have no horizontal component but only the sine component, which means it does not have any horizontal component but the only vertical component, that is 25 Newton. For this force 30 Newton making an angle 45 degree with the horizontal axis again, then this will be 30 cos 45 degree and this will be 30 sine 45 degree. For the force 35 Newton making an angle 40 degree with the horizontal again, then this will be 35 cos 40 degree and this will be 35 sine 40 degree. Now for the first step we have to add all the horizontal component of this force system, taking into consideration the sine. Let us say if this is xy axis, then the force acting in this direction will be positive, in this direction will be negative, in this direction will be positive, in this direction will be negative. So taking these signs into account, we are now going to add all the horizontal components. So sigma h will be given by, starting from this force, 20 cos 30 degree, 20 cos 30 degree minus 30 cos 45 degree minus 35 cos 40 degree. This 25 Newton has no horizontal component and this is in the vertical direction only. So by doing this calculation we will have sigma h is equal to minus 30.7 Newton. Similarly, sigma v, the algebraic sum of all the vertical components. So the first vertical component of this force is 20 sine 30 degree in the positive direction. So 20 sine 30 degree plus this 25 plus 30 sine 45 degree minus 35 sine 40 degree. Now by calculating this equation we have sigma v is equal to 33.7 Newton. Now we have sigma h and sigma v. Now calculating magnitude r by the formula sigma h square plus sigma v square. So sigma h is minus 30.7 square plus sigma v is 33.7 square under root. We have the magnitude of this resultant force as 45.6 Newton. Now the last step to calculate the theta. So tan theta will be given by sigma v upon sigma h. Sigma v is 33.7 divided by sigma h minus 30.7. It comes out to be minus 1.098, or you can say that theta is equal to tan inverse minus 1.098, and the theta comes out to be minus 47.7 degree. Now the negative sign in this angle indicates that angle is not calculating anti-clockwise, but it is to be calculated as clockwise. Now let's see where this resultant is present in this force system. So this is x-axis and this is y-y. Sigma h is negative and sigma v is positive, which means the resultant will lie in the second quadrant, and the angle will be this 47.7 degree. So this is how we can calculate the resultant of the force system by using analytical method. Happy learning.